Hey everyone, how you doing? My name is Scott Jenkins. I'm senior editor at Chemical Engineering Magazine. As part of the magazine's continued coverage of solids handling, I wanted to just make a quick video to talk about some of the or how some of the major industrial trends are showing up in operations involving bulk solids materials. So processes involving solids are incredibly diverse, and they're incorporating everything from handling ores in mining operations to handling active pharmaceutical ingredients and drug making. And in between, you have foods, agricultural products, waste materials, specialty chemicals, and others. Just a really wide range of granules, powders, aggregates. And one of the results of all this diversity is that each subsector has kind of its own nuanced picture. And there may be trends specific to each, but what I tried to do is just sort of generalize a little bit and talk about some of the developments that kind of apply to all the sectors. And in a lot of ways, these solids handling trends sort of mirror developments in other industrial sectors, but they're being applied in ways that are specific to solids. So there's probably a lot of ways to do this, but my attempt here is sort of to kind of categorize these trends into like three different buckets. So the first one, I guess I would call maybe solids 4.0, which is sort of playing off the term of industry 4.0, meaning the application of digitalization and artificial intelligence tools that are found in industry 4.0 initiatives into solids operations. So there's many ways that these modern digitalization tools are showing up. Some examples include machine learning algorithms being used for predictive maintenance programs for solids handling equipment, such as conveyors maybe, or mills or other machinery. Some other ways that we've seen quite a bit are the use of digital twins, of plant unit operations, in solids being used to visualize flow patterns in hoppers, for example, or simulate blending dynamics, or predict maintenance needs for equipment. A lot of times digital twins are being used to de-risk scale-up operations and also for training purposes. And another way digital twins are showing up is kind of focusing or tracking a process with a difficult material or difficult flowing material, and try to use that to predict set point adjustments. A big part of solids handling is material characterization, and there's definitely been a lot of AI tools being used to enhance material characterization. We've also seen an increased use of autonomous vehicles and robotics in raw material handling and inventory management. For example, robotic bag dump stations or palletizing machines. Many of these are kind of aimed at increasing worker safety by moving them away from high risk areas and away from tasks, and also try to boost efficiency as well. Another example of the use of AI is in load optimization and transporting bulk materials, and also AI enhanced level sensing in storage silos, where data from multiple sensors are combined to address difficulties like varying surface topology or dust interference. So I guess the second area that and obviously that's not exhaustive in any way, but just giving a few ideas there. But I guess the second bucket or the second category that I would like to talk about a little bit is these technology and equipment engineering improvements that are not having directly to do with digitalization and artificial intelligence. So these are kind of improvements that are aligned or with a motivated by strategic business goals, potentially improved performance or efficiency, increased reliability of an operation. Some of these are aimed at achieving higher performance and accessing specific properties of a product. And then others are aimed kind of at cutting costs through better asset reliability or more efficient operation, lower energy consumption, maybe reduced waste. So there's kind of a general trend, I guess, of using engineering equipment that can handle, or rather engineering equipment to handle higher throughputs with lower energy consumption. A couple of examples of that are like the use of higher efficiency blowers and compressors for conveying systems, the use of variable speed drives for mechanical equipment. We've seen in areas in industries where contamination is a concern, a lot of improvements in hygienic design, trying to eliminate dead spots and areas where bacteria can breed. Clean in place technology has improved also. We're also seeing an increased use of dense phase pneumatic conveying to sort of increase pressures or use higher pressures, but lower material velocities in an effort to reduce particle breakage and material degradation, as well as lengthening pipe lifetimes. We've also noticed a focus on flexibility. So there's more use of modular or scalable systems to allow for easier reconfiguration, customization, and expansion. And also a more use or increased use of rental equipment sort of to address variable demand of certain products. Some other areas of advancement here are, improved devices for promoting flow, so flow aid technologies in solids and hoppers. A lot of interest in advanced materials for building equipment, including ceramics and hardened steel alloys in areas where there's high wear rates, and try to, in an attempt to kind of reduce maintenance downtimes. We're seeing some examples of electrifying the power delivery systems for solids handling machinery, such as conveying, as a kind of a decarbonization strategy here. And then one last thing I'd just like to mention is kind of I guess what I might broadly describe as engineering surface properties of powders and other solid materials. So there's a lot of attention on and advancement actually in trying to better control interparticle interactions by engineering the first few nanometers or the outer couple of nanometers of a particle by either applying a coating or by creating a protective layer on inner reactive particles. Core shell powders, for example, have either a metallic or ceramic core, but have an engineered outer layer to kind of control some of those interparticle interactions. So could probably go on for a while on some different examples here, but I just wanted to get to our third bucket here just to kind of wrap things up a little bit. So I guess the third category that I would say is we could call it new applications. So what I mean by that is the advancement of solids handling equipment and technology specifically for evolving, or rather specifically for addressing the needs of evolving or emerging markets or new feedstocks. Some examples of this are battery raw materials for energy vehicles and grid energy storage. I think I said energy vehicles, I meant electric vehicles. electric vehicles and grid energy storage systems. So these battery electrode materials is a growing area. You have an increased need to handle waste materials, such as recycling plastics, used electronics, municipal solid waste. A lot of these recycling initiatives require handling a lot of these different kinds of solid streams. Then the other one I'd like to mention too is an increased need to handle powdered metals for additive manufacturing or 3D printing. A couple other things in terms of growing market sectors. There's growing demand for copper and other metals for cabling in AI data centers. We've seen a big growth in those and all the materials that go into that. So you also have kind of a demand for eco-friendly construction materials. So that's a growing area. A lot of nanoparticles or materials that are engineered at the nanoscale for use in composite materials or advanced composites. So plastics recycling, batteries, waste handling, some of those other things involved with critical materials and metals. So those are some of the areas that we're seeing a lot of activity and growth in. So I hope that provides a little food for thought, and just wanted to put that out there, and then encourage you to keep checking the pages of Chemical Engineering, and also www.chemengonline.com for more articles and insight on solids processing and handling. So until next time, I'm Scott Jenkins. Wish you all a good rest of the day.